Okay, so we're going to talk about defining a circle. So everybody knows what a circle is, and I can actually put one up there for you so we can take a look. If I did a circle is defined to be, let me see if I can put a center in here real quick. That's pretty close to the center. A circle is defined to be every possible point that is equal distance from one particular point, and that point is called the center. So what I mean by that is, if I were to take and draw a line from here out to here, or from here over to here, or from here up to here, or from there, all of these lines that I've drawn in red would have exactly the same distance. So obviously you could do an infinite number of them all the way around the circle, and all those points that are going to hit here, 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 and so on everywhere, it's all going to create a circle. So now I'm going to try and erase some of that. See if I can leave my center in there, or at least pretty close to. I'll just draw a new one. Oh, it's still there. Good. So every point that is equal distant away from the center. Well, really, how we develop the a formula to come up with the equation of a circle is from the distance formula, which is why this one goes so well with the section 2.8 in the book. So this is the distance from the center out to any point on the line. What we call the center is, it's going to be an ordered pair. It's going to be an xy value, but we actually call it by the ordered pair h, k, and that is your center. This particular line has a specific name to it. So the distance from the center out to any point we call the radius, and we call that little r, and that's the radius. So the question is, if I take this blue point right here, which is on the circle, that's where it hits, and I want to find the distance from that point to this point right here. Well, this point out here on the outside of the circle is just some other x and y value, and we'll call that one x and y, which is probably why they called the center h and k, so that it doesn't have another x and y in there, although we could have used, you know, a sub 1, sub 2, something like that. But in this case, this makes this a little bit easier to do. If I want to find the distance now between 2 points, we know how to do this. It's based upon Pythagorean Theorem. And the idea was, if I take the horizontal change of my x values and the vertical change of my my y values, it creates a right triangle, where this over here would be A, this over here would be B, and then up there where the R is would be C, but we're not going to call these A and B in this case. Since this right here on the bottom is the change in the x values, well, the second x value is x. The first x value is h. So the distance here on the bottom is x minus h. And then the distance on the y values, well, this is your second y value, this is your first y value, so the distance here is y minus k. And then the distance, like I said, from the center out to the blue point is r, that's your radius. If we put all this together with the Pythagorean theorem, whoops, too far. The Pythagorean theorem says, if I take one side of the right triangle squared plus the other side of the right triangle squared, that has to equal the hypotenuse squared. So what I have for a circle is x minus h, that's the first side, squared, that's like your a squared, plus y minus k, which is like your b squared, and that equals r squared. That is the standard equation for a circle, where h and k represent the center, and r represents the radius of the circle. Okay, so if we wanted to find the equation of a circle given some information, now that we know that the center, let's write this out just to make sure we have it, the center is the ordered pair HK, the radius is R. So now if I gave you an example, so let's do example 1 here, which says basically let's write the equation of the circle if I give you the center and the radius. So let's write an equation of a circle with center 0, 0 and radius let's do radius 2. Well, the center is H and K. So this is H, this is K, this is R. I am literally going to plug 0 in for H, 0 in for K, and 2 in for R, and I've got the equation of my circle. So here's H, here's K, here's R. Notice the equation is x minus h. So I'm going to do x minus whatever the h value is that they give me. So in our case, we've got x minus 0, and then we square it, plus y minus k value is also 0, and then we square it, and the r value is 2, and we square it. That is the equation of the circle, which has a center right at the origin at 0, 0 and a radius of 2. Now we're going to simplify that because we're not going to typically leave it like that because we do know what x minus 0 is. X minus 0 is just x, so that's x squared. Y minus 0 likewise is just y, so that's y squared. And then 2 squared is just a number, which is 4. That is the most common way that you would see the equation of that circle with center at 0, 0 and radius 2. Okay? Let's try another one. This time, we're not going to make it at 0, 0, so it's not going to look quite as nice as that as the end, but it's going to be pretty easy still. So we'll call this example 2. And I'm not going to rewrite the entire question because we're doing the same thing. So I'm just going to tell you that the center is at -2, 3, and the radius is 4. So let's write the equation of a circle. And remember, it's x minus h. Here's h. Here's k. Here's r. So the equation of the circle, x minus. Now be careful because h is negative, so it's going to be x minus a -2 squared plus y minus the k value, which is 3, squared equals 4, which is the radius, squared. And then we'll simplify. We don't need to FOIL all this stuff out or anything like that. We just need to simplify if we have a minus minus. So we'll clean it up a little bit basically. So that x minus minus 2 is x plus 2 squared plus y minus 3 squared. And then of course we want to simplify the 4 squared, and that just gives us 16. Again, that's the standard equation of a circle. And this one was centered at -2, 3 with a radius of 4. Okay, that's not so hard if I give you the center and give you the radius. So maybe I'm going to give you the equation instead, and I want you to tell me what the center is, and I want you to tell me what the radius is. So we're going to kind of take the idea backwards. So this will be our next example. So we want to find the center and radius given, let's see, let's go with x minus 2 squared plus y plus 4 squared equals 9. So now we want to actually find the center and the radius. All right, well this is h. Be careful about k, because this doesn't follow the normal form right there. That's not y minus something, it's y plus something. Well, in order for us to get that, that would have had to have come from y minus a negative 4. That's the only way we'd have gotten a y plus in there. So that means k is negative 4. And then r, because remember that 9 is r squared. So this r, oops, shouldn't be an equal sign there, sorry. R is going to be 3, because it's going to be the square root of 9. And we're only concerned about the positive square root. So, that being said, my center is the value of h and k as an ordered pair, which is going to be 2, negative 4. And the radius is the square root of the right side, which in this case was 3. So that circle was centered at the point 2, negative 4, with a radius of 3, meaning that the center is at 2, negative 4, and then from there, every direction you can possibly think of from that center has a distance of 3 out to the edge of the circle. Okay, hopefully that makes some kind of sense. If you needed to, if we needed to find the domain and range of this, we'd kind of want to sketch this thing so we could actually see it. So if I wanted to do a center at 2, negative 4 with a radius of 3, easiest thing to do, because remember domain is x values and range is y values, the easiest thing to do here is to start with the center. So the center is at 2, negative 4. 1, 2, 1, 2, 3, 4. So that's down here somewhere. And then it says the radius is 3. Drawing a radius at the diagonals is tough, but drawing a radius up, down, left, and right is relatively simple because it's just going to move 3 units away. So in our case, if I move 1, 2, 3, let's see, 1, 2, 3, 3 units up, that's going to put us right there. If I move 3 units left, 1, 2, 3, that's going to put us over here. So I'm going to have to draw some extra tick marks in here, I think. Something like that. If I move 3 units down, 1, 2, 3, and then if I move 3 units right, 1, 2, 3. Now that's not a very good circle. It doesn't look like I'm going to try and use the tool here, and I'm going to probably be way off. But that's the idea of the circle. So let's see how badly I did here. Well, it's not extremely horrible, but not great either. So my old adage is, if you miss the graph with your dot, make your dot bigger. And I no longer miss the graph with my dot. There. Now it looks like I actually knew what I was talking about. So domain is the list of your x values. Well, x goes from here to here. So that's going to be from negative 1 up to 1, 2, 3, 4, up to 5. So my domain of that circle goes from, and it includes the endpoints because they are part of the circle, negative 1 to 5. My range goes from the bottommost y value, which is here, up to the topmost y value, which is there. So it looks like that's going to go from 1, 2, 3, 4, 5, 6, from 7 on the lower side, so negative 7, up to negative 1, and that would be the range of that circle. And that's kind of the idea. If you needed to figure this out, you would want to sketch yourself a drawing, figure out how many units up and down, and it's based upon your radius that you would have to go, and then left and right, which is also based upon your radius. That would really tell you your starting and ending points for your domain and your range. Okay, probably the hardest part about doing these, and this will be the last thing that we talk about, is if you are given what is called the general form of a circle. And the general form of a circle, it's not commonly, or it's not easily used, but it's x squared plus y squared plus dx plus ey plus f equals 0. And you might be looking at that thinking, whoa, that's a big formula, and it is. Hopefully you'll see why it's not horrible, but you are going to have to be able to do one of our old solving techniques, which is completing the square. And when I told you that it's not heavily used, this is one of the few places that actually really is used. So our example is, because we want to find the center and the radius of one of these things. So we're going to be given this graph, x squared plus y squared plus 4x minus 6y minus 23 equals 0. So believe it or not, that is a circle. It'd be hard to tell by looking at it because it doesn't look like the other form that we had. But what you should see is that d, e, and f are just the coefficients of x and y, and then f is the constant at the end. Well, as of right now, the right side is 0, which means that you would have no radius. That doesn't make any sense. That wouldn't actually be a circle. So the first thing we do is we always take the constant and we add it to the right-hand side so that we're going to get an actual radius on the right-hand side. So we'll add 23 on both sides of this, and we'll get x squared plus y squared plus 4x minus 6y, and then equals 23. Now we have to try and get it into the correct form. We're going to have to do completing the square 2 different times. What we need to do is we need to regroup those 2 together, and then we need to regroup these 2 together because we got to put the x's with the x's and the y's with the y's. So here's what we're going to do. We're going to take x squared plus 4x, put it in parentheses. I'm going to leave a space. And then I'm going to take y squared minus 6y, and I'm going to leave a space, and then equals 23. The reason I am leaving this space is because I need to complete the square with each one of these. So if you guys remember, completing the square was taking this middle term, 4, dividing it by 2, and then squaring it. That completes the square. So 4 divided by 2 is 2. If I square that, I get 4. That completes the square of that one right there. However, I've just added 4 to the left side of an equation. In order to keep the balance, I also need to add 4 to the right side of the equation. We'll do the same thing with the y part. We'll take this middle term, negative 6, divide it by 2, which is negative 3, and then square it. Negative 3 squared is positive 9. Again, I have arbitrarily just now added 9 to the left side of the equation. I must add 9 to the right. Okay, so far we're doing pretty good. To actually write this in the proper form now, we basically have to factor each one of these parentheses. But when we do that, the first one, if I factor it, is going to give me x plus 2 times x plus 2, which is x plus 2 squared. The second one, when I factor it, because it's also a perfect square, is going to give me y minus 3 times y minus 3, which is y minus 3. Oops, not cubed. I don't know what that would give me. Oops, come on now. That's weird. I don't know why that was happening. There we go. And then we simply add all the constants up on the right. So 23 plus 4 is 27, plus 9 more is 36. Now this is in a form that we are used to seeing. So the center is HK. Here's H. Except that that's not really H. I'm sorry, here's K. This is not in the right form, right? Because that's x plus. It needs to be x minus. So really, this should be x. oops, this should be x, wow, come on, x minus negative 2. So h is negative 2, k is 3, and then r is the square root of this side, which is 6. So my center is at negative 2, 3, and my radius is 6. All right, and that's how you would be able to solve a circle in that form if it's given to you in the general form. All right, I think that just about covers everything we need to cover with circles, so there you go.